Hi, welcome to Aviator Zone Academy. My name is Felipe, and today I'm going to be taking you through all the steps that you're going to be taking for every single flight you do here with us. We're going to start off by doing the performance and weight and balance information for the aircraft that we're going to be flying. To do that, we're going to come over here, and today we're going to be flying November 902 Alpha Zulu. So we're going to open this, grab one of these sheets, and then we're going to go take a seat, complete all this information so that we can get flying. All right, so we're going to go ahead and start filling out this form. We're going to start with today's date. We'll use January 1st. 2020 as our example, and I'm going to use John Doe as the pilot. When it comes to gathering the weather information, it all depends on what the student's preference is. Most of our students use ForeFlight for gathering the weather, so that's what we're going to be using for this example. But don't be limited to just ForeFlight. There's also free resources online, other applications, and even the government offers that weather information. Let's go ahead and take a look at ForeFlight for this example. Go ahead and go to the ForeFlight app and copy my weather down. So we have winds 210 at 8 knots, 10 miles visibility, few at 2,500, scattered at 4,400, and broken at 7,000, temperature of 27, dew point 25, and an altimeter of 2,991. To find our headwind component, now that we have that 60 is our degrees of difference between the wind and our runway of use, we want to plot 8 knots somewhere on that 60-degree line. We don't use these numbers because that's the answer, and we don't have a problem if we know the answer, right? So we're going to start with 60, and then we're going to use these lines as an arc. That's 5 knots, 10 knots, 15, 20, and so on. So what you want to do is if the winds are 40, you want to plot 40 and 60 together. That's not the case today. If it's 30, then you want to use the 30 line and so on. That's why you don't use this, because then if it was 30, you would be plotting it here, and that's not what we want. We want 30 on this line. It's an arc. In our example, 60 degrees, 8 knots. We're going to go all the way down here, and we have to kind of guess more or less where 8 knots is, and I'm going to say somewhere around here. So the 8 knot line, it kind of looks like this. Right? It's just an arc. Once we do that 8, we find the 8, we make a big dot, and then we do a straight line down and a straight line across. I'm horrible at making straight lines, but you get the point. And we read that the headwind component is for about 4 knots, and our crosswind component is about 6 to 7 knots. And we're going to go over here, and we're going to put our headwind component. We said it was about 4 knots. And our crosswind component, we said it was going to be somewhere around 6 knots. Now let's go ahead and calculate pressure altitude. For pressure altitude, we have a formula, and we add it into the sheet to make it easier for you. So it's going to be 2,992 minus the current altimeter setting. So I'm looking at the weather information, and today's altimeter is 2,991. We're going to multiply that by 1,000, and then we're going to add FE, which is field elevation, the field elevation here at the airport. It's very important that you put that formula exactly how it is on the paper, because this number sometimes is going to be negative, and that's very important because it can be lower or higher. So don't change this to make the math easier. Use your calculator. In our case today, it's pretty easy because we're really close to standard pressure. So 2,992 minus 2,991 is going to be 0.01 times 1,000 plus field elevation. Now, how do we find the field elevation? The field elevation is going to be found on ForeFlight. So if I go to the ForeFlight and I look at the airport page, right on the top where it says the airport name, it has the elevation. In our case, it's going to be 10 feet. So that's going to be plus 10 feet. Now, I'm going to use my calculator. And it's going to be 0.01 times 1,000, 10 feet, plus 10 feet. Today, pressure altitude is going to be 20 feet. And I'm just going to write that in for pressure altitude. Now that we have our pressure altitude, we know that it's going to be 20 feet, and I'm going to put 20 feet. Now, to calculate density altitude, we're going to need our CX3. So let's go pull that out. So we're going to use a CX3 to demonstrate how we calculate our density altitude. The CX3 is nice because it gives you pressure altitude without having to do all that math. we're going to start off by going to altitude and select that. And it says IALT. That means your initial altitude, which our airport's going to be 10 feet. We're going to go ahead and set the barrel. Oh, yep, 10. Our barrel, we're going to go ahead and put it in. This one's already preset because we already ran through this example, and it's going to be 2909 Then you press enter. And it gives us the pressure altitude, in our case, is 20 feet, which is perfect. We got that by doing the math. Now we need our temperature, right? Pressure altitude is density altitude corrected for non-standard temperature. So now we're going to put that temperature to correct density altitude. And the temperature, according to the ATIS today, is 27 degrees. Now that's Fahrenheit. We have to change that to Celsius. So how do we change that to Celsius? We press the set unit and it changes to 27C. And now we get a density altitude of 1,413 feet. So we're going to go ahead and put that in our sheet. Now we're going to move on to the weight and balance. Weight and balance is pretty simple. And once you know the formula, you can calculate weight and balance for any airplane. In our example, we're going to be using our 172. And I'm going to go ahead and make up some of the weights here just because it's going to be different for every different example. So in the pilot and front passenger, I'm going to say that we have combined 300 pounds. In the rear, I'm going to say that we have 150 pounds. Fuel. The fuel, we have to put it in weight, not gallons. So every pound of avgas is 6 pounds, and we have 40 gallons, so that's going to be 240 pounds. In the baggage compartment, I'm going to just say we have 5 for the example, and then what we're going to do is we're going to add all these up using a calculator to find out how much our total airplane weighs. So let's go ahead and do that. So we have a total loaded airplane of 2,191.48 pounds. If we look up here, it's going to give us the max weight that we can take off, 2,400. So right now we're within weight. We're going to find the balance now. A quick formula that I always teach all my students is weight times arm equals moment. So I just do this, times and equal, right? We can remember that, times and equal. Weight times arm equals moment. And then we're just doing simple algebra. In this case, we're going to be doing 300 times 37, and that's 11,100. Then we're going to do 150 times 73. Our total moment is going to be 91,897.79. Now, common mistakes here, people forget to add this number up here. Same thing on the weight, okay? So don't forget to add that top number. And another common mistake is people add all the arms and then put the answer here and say that's the arm. Well, that's not the arm. Now we have to use algebra to find the arm. So if we multiply weight times arm equals moment, to change the math around, we're going to need to find arm. Arm equals moment divided by the weight. So we're going to divide this number by the weight. It's going to give us 41.93. I'm going to round up to 41.9. So our arm is going to be 41.9. Now that we have the arm and we have the total loaded airplane, we can go into this crazy looking chart, which is actually pretty simple to use. What we want to do is we want to find the loaded airplane weight. In our case, our airplane weighs 2,191 pounds. So that's going to be somewhere around here, because this is 2,200. I'm going to round it up to 2,200, so we're at that 2,000 line. And then our arm is 41.9, so down here I'm going to look for 41.9. I'm almost going to use 42, so I'm going to make a line here. Now I want to find where these 2 points intersect, and it's going to be right here, and make a big dot. That's going to be where the aircraft center of gravity is going to be at takeoff. And we have 2 boxes here. We have a big box that says normal category, which is actually this section here. And then we have a little box, which is the utility category. Now the difference in the two is that one can pull more G's than the other, and your instructor will demonstrate that and talk about that later on in ground school. But for our demonstration purposes, we want to go ahead and make sure that the aircraft falls between this box. If it doesn't, it's not within balance. Now, if the airplane is up here, it means that the airplane is overweight because it's on top of this. So we want to decrease our weight to get back into this box. if the airplane is here, it means that the center of gravity is forward of the limits, and we have to put some weight in the back of the airplane so that we can get into the weight and balance limits, and then that's going to increase our weight. So this is how much weight we can add, and then how much we can move it back. So you'll get a better understanding of this later on in weight and balance, but for now we want to make sure that dot is inside this box. That completes the weight and balance section. Now we can move over to performance data. For the performance data, we're going to need the maintenance manual for the airplane. And in the maintenance manual, we're going to go to, guess what, the performance section. In the performance section, we're going to move through the manual and find the takeoff distance chart. And it kind of looks like this. Now, for the takeoff distance chart, we want to use it depending on the weight that the airplane is at. In our case, our airplane is at 2,200 pounds. Very important to always read the notes and read the top of these charts. So we're at 2,200 pounds and 2,000 pounds. We're using this chart. There's another chart that is used for 2,400 pounds. We're not going to use that one. And always read all these notes. This is a check rate question right here. So make sure you know how to find all these notes and what they all mean. So in today's example, sorry about the glare, these are pretty shiny sheets. We are at 2,200 pounds, so we're going to start with 2,200 pounds here. And then it's going to give us our liftoff speed. So our liftoff speed is our rotation speed, and then our speed at 50 feet is going to be our Vx. So coming over here where it says Vx, we find that number by using the 50 feet speed. We rotate at 49, climb out at 56. These are the shortest number that you want to use to be able to make a short field takeoff. On a normal takeoff, we take off higher than this. But if we're going to clear an obstacle, this is the speed that we want to fly. So Vx is 54. We're going to write that in here. Now, notice that it asks us for pressure altitude and not density altitude. The reason it doesn't ask us for density altitude is because we're correcting for non-standard temperatures up here. So our our pressure altitude today is 20 feet. So we're going to go ahead and use sea level. Cessna doesn't give us anything for under, and they don't give us anything for over. So we're at sea level, and our temperature is going to be 27 degrees. We're going to round up to 30. Always be conservative on these numbers. So at 22,000 feet at sea level, with a temperature of 30, our ground roll is going to be 805 feet. So our takeoff distance is going to be 805 feet. And if we want to clear a 50-foot obstacle, our takeoff distance is going to be 1,470. 1,470. That completes the takeoff distance. Now we're going to move over to Vy and then finally our landing distance. So for a maximum rate of climb, Vx, we're going to find it by using this speed here. So they only give us for a heavy airplane, 2,400 pounds. They don't give us for anything else. We're taking off from sea level. Our Vy is going to be 76 knots. So we'll put that in here. If for some reason the pressure altitude was 6,000, it will go down to 73. So that's why we use these charts, because those numbers are constantly changing. Now, landing distance. This manual is set up to take place as you're flying, basically what you're going to be doing on flying, right? So we start off with a takeoff, we go into the cruise, performance, and then at the end, they give us landing distance. And again, Cessna only gives us charts for 2,400 pounds for the landing, which will definitely be way under that. Again, very important to read all the notes. And now we're going to go into the chart. So we're at 24,000 pounds on the weight, and we're taking off from, we're landing at sea level. Our speed at 50 feet, we want to be somewhere around 61, which we use about 65. And now our temperature is 30, so our ground roll, meaning the airplane needs 570 feet of runway to land. Not much. And then landing to clear a 50-foot obstacle, it's going to be 1,325. That completes the performance section of the weight and balance sheet. Now, let's move into the risk management. When it comes to risk management, this is one of the easiest charts to complete, and it takes very little time to do. We'll start off with being I'm safe, and in this case, I am safe, so the risk is low. I'm going to circle low. It's not a night flight today. I'm going to put no. The weather is definitely VFR. The winds are less than 10 knots, so I'm going to select 0. VCTS and LLWS stands for Vicinity Thunderstorms and Low-Level Wind Shear. We don't have that today, so I'm going to go ahead and press no. We have no expected turbulence. It is not an unfamiliar airport for John today, and it is going to be a dual flight with an instructor. Then we add up all these numbers, and in this case we have 0. So 0 to 3 is a low-risk flight. We'll go ahead and circle low. If you have 4 to 7 is moderate, 8 to 12 is high, and greater than 12 is very high. So make sure you always complete this chart. The rest of the paperwork is left for our instructors, and that's where they're going to put the times in and out, how much flight time, if they added oil, or anything wrong with the airplane, and always make sure that your instructor signs these sheets. If you have any questions regarding to these sheets, make sure to consult your instructor, and they'll be more than happy to help you and go through it so that you have no questions about it. Thanks for watching, guys, and safe flying.